Hello friends, we are continuing the topic in the curves. Till now we have completed the linear methods in the curve and we have started the angular methodology. In that we have started with the Rankin's deflection angle method, and it is totally depends upon the instrument based. In that advancement of Rankin's method, that is the two theodolite method. The two theodolite method here, instead of using one theodolite at the position of either T1 or T2, we need to place two theodolite in T1 and T2. So at one position, say T1, we need to set the deflection angle del 1 from the tangent, and from T2 we have to set the del 1 from the long chord. So where they get meet, with the help of a helper, they need to move either forward, backward. We can fix the exact point F. So similarly you can increase del 1 plus del 2 gives the next position here. Similarly del 1 plus del 2 next FG. So this can be continued for n number of times, even for 20 seconds also we can set the point. That is the greatest advantage of two theodolite method. So the accuracy of smoothness of the curve can be achieved very neatly using two theodolite, but it is a time consuming process. But when the curve should be set very precisely, this methodology is adopted in many major projects, right? So even in the curves, in the bridges, flyovers, there they check this changeover very keenly. If there is any mistake, the travel or the accidental issue will be more. So this is the one of the advanced level of Rankin's method. Only same calculation del 1 del 2, all the calculation what we have seen in the Rankin's methodology, that calculation alone, but we are using a method, sir. Two theodolites are set up, then we continue the same process based on the tangent and the long chord, right? Next is the what are the obstacles in setting out simple curves, that is a horizontal curve. Case 1, when the point of intersection is inaccessible, right? If what will happen, how we can solve it? We have to assume somewhere else it will be, such that we have to start by either T1 or T2. In the case of 2, if the point of commencement is inaccessible, only choices from point of intersection or from the point of tangency. And the third case, when the point of tangency is inaccessible, vice versa, right? So how we can draw the same curve in our paper with the proper scale, and it can be transferred to the ground very easily, right? That is the ultimate aim of or advantage of the surveying, right? So case 4, when both the point of commencement and the point of tangency is inaccessible, what we can do? Based on the point of intersection, we need to draw the diagram, and we need to avoid those T1 and T2 such a way that at the next existence point in the tangent we need to proceed the curve. Case 5, when obstacles to chaining, we couldn't do any chaining or any measurement or any, there we have to go for the tachometric principles, right? Since I could not use the chain or tape, the tachometric constant principle has to be adapted. So based on the field condition, how the logics can be applied, that is the role of a engineer with the knowledge of surveying, right? Next is the transition curve. What is transition curve? You should remember, the diagrams look like same of simple curve, same deflection angle, intersection point, T1, T2, the straight proceed A, B, origin of the curve with the radius R. But apart from that, this portion is along the circular or simple curve. From the point T1 to the starting point of the circular curve, and from the end of the circular to to the T2, this portion is the transition curve with different radius, say RT, right? So that radius, and it has a separate. Why it's so? If this circular portion itself we continue, it may leads to far further distance, or the curve may be not smooth and it may be sharp. So the turn, while the turn of a vehicle, say two-wheeler or four-wheeler, the turn won't be sharp. To avoid such a condition, we need to make it smoother. We need to provide the transition curve, say that is the super elevation you may study in the transportation engineering, to avoid the over skidding of the vehicle, right? Either two-wheeler or a four-wheeler. What is I think you remember the force, centrifugal force. When the centrifugal force while turning, it's not governed, the two-wheeler or the car may pull down directly opposite to the direction, and it may overturn and major accidents may happen. For that, to overcome the centrifugal force in the opposite direction, the road will be raised and the portion of the road also widened, right? That is the purpose of providing this super elevation. That super elevation portion, it's totally depends upon the transition curve part, right? So this portion alone is true transition curve, and it will be raised. If it is a right-handed curve, the left side of the road will get up. Here it is the same right-handed, right? So from here, if you see it is a left-handed, means the opposite way, right? You have to remember, to avoid the sharpening of the curve and make the travels very smooth, at the two ends of the circular curve a small changeover is provided. So this portion is along the transition. The combination of two transition and circular curve is the transition curve methodology. So what are the requirement of transition curve? The tangential to the straight. Say the curve must be tangential to the straight, right? Meet circular curve also tangential. See where it meets the circular curve, here also it must be tangential. That are the requirement of setting the transition curve. At origin, curvature should 0. What is at origin? Say, consider this is the origin. The curvature obviously from T1 to this portion, it is obviously 0, right? Curvature should same at junction of circular curve. Say here and here the curvature must be same, right? Rate of increase of curvature must be equal to rate of increase of super. The curvature, if you increase, the super elevation also has to be increased. It's both are directly proportional. Length of transition curve is equal to full super elevation attained. How much you have attained the super elevation, that is the length of the transition curve, that portion alone, right? The purpose of transition curve, curvature is increased gradually. Medium for gradual introduction of super elevation. For introducing the super elevation is the purpose of transition curve. Provide extra winding gradually, such that we can avoid the skidding of vehicle. Advantage of using the transition curve: increase comfort to passenger on curve, reduce overturning, allow higher speed also, less wear on gear and tire for the vehicle. These are the advantage while we providing the transition curve. Types of transition curve we can provide. For railway purpose, majorly the cubic parabola is adopted. Say here, this is the cubic parabola, the major axis, the minor axis. The cubic parabola is adopted for the railway. since sharp turning like this turning, if you provide in the railway track, the train cannot be operated, right? So majorly the cubic parabola is adopted for the railway curves, and for the remaining spiral or clothoid, say spiral this way or somewhere else or this way, the spiral methodology is adopted wherever in the highways, right? So here the radius is directly proportional to the distance, and compared to spiral or clothoid, the lemniscate is the major thing used for roads. What is lemniscate? See, this is the lemniscate, where the minor axis and almost the major axis are similar to each other, and the curve is in both the direction, it is equally half. So such a thing is adopted in the road lemniscate. These are the types of curve you may study in your mathematics, so try to remember those properties which is directly applicable in our construction of roadways and railways, right? Next portion of the curve is the vertical curve. It is of, already we have discussed about the two type, summit curve and the valley curve. What is summit means? If the road is increased in the elevation and proceed and reach the high point and get dropped down. So this is the summit curve. It is happened in the longitudinal direction, the curve. Till now we have seen the horizontal curve in this direction. Here it is the vertical direction, how the flyover get increased and drop down. So it depends upon what the grade of the say G1 plus G2 plus or minus, how when there is a increase in the grade, it is plus will be given. When there is a drop in the curve, it will denoted by negative, right? So based on this, where the straight get meet, the point A is in virtual point. In the horizontal circular curve, we can pinpoint the point on the ground. The I point or the V point can be fixed, it is in this position. But in the vertical curve, the meeting point, it is in space. We have to assume it will meet here, such that the curve must be like this. And it is depends upon the grade and how smoothness we have to provide. Sometimes the G1 value and the G2 numerical value may be same, sometimes different, right? Similarly for valley curve, when the straight there is a drop down and then we have to increase. So here say G1 minus, here G2 plus, right? And obviously you remember it is the apex distance from the center of the curve to the, but this is also in virtual only, we couldn't mark on the ground, right? In the calculation only we can draw and see. So these are the two types adopted in the vertical curves. The length of the vertical curve can be obtained is equal to total change of grade, that is G2 minus G1 or G1 minus G2, whatever the things, the change of the curve. If it is a summit curve, G2 minus G1. If it is a valley, G1 minus G2. And substituting that G2, you need to give the value of G2 with the symbols. Minus means minus, here plus means plus. That exact value has to be given, divided by rate of change of grade. The rate of change of how the grade of the curve changes. So the grade will be in percentage and the rate of change of grade are the symbol used. So this is the formula you have to remember, right? So hope you have understood the concept of horizontal curve, transition curve. Then we have seen about the vertical curve. We will see some problems in the next video. Thank you, friends.